Okay, this video is supposed to be a continuation of the previous video. There was a glitch in the example. So let's go with this particular example that we began in the last lecture. And in this example, we have a 2D steady velocity field that where u is equal to x squared minus y squared, and v is equal to minus 2x times y, and you want to derive a streamline pattern. Okay, to derive this streamline pattern, as we learned in class, this will be equal to dy divided by v, dz divided by z, divided by w, sorry. And then from here, if you go and look at the equations that we have here, you see this gives you dx x squared minus y squared, but this is x squared minus y squared. And this has to equal to dy minus 2xy. This is this right here. And this will be dz, and since we don't have a w, that will be 0. And what you have to realize is this is very common because the streamlines do not vary with z. So it's 0 because the streamline does not vary with z. Okay? So basically, in synthesis, what you're left with the problem is these two parts right here only. Okay? So with that said, we can continue in our problem now. What we have really in the problem is dx x squared minus y squared is equal to dy minus 2x. I can multiply on both sides, so I can y here, I can multiply this times this times this, and just note that what you really end up with this problem is this: minus 2x y d of x is equal to x squared minus y squared times dy. Okay, so this problem, one way you can look at this problem is this is actually the exact differential equation. This is exact differential equation. Okay, and it's the exact differential equation. If you realize that we can write, if we had f is equal to f of x, y, and then df, if I use the chain rule, I can write this partial of f respect to x, d of x, plus partial of f respect to y, d of y. Okay, and then if you take this equation right here, right, and I bring this on this side, you can see that I can rewrite this as follows. I can say df is actually, this is going to be 0. If I take this on this side, will be 2xy d of x plus x squared minus y squared d of y. Okay, so if you start comparing these terms right here, you can immediately see that this term is actually the same as this term right here. Okay, so from here, df dy will be x squared minus y squared, and then from here I could integrate on both sides. I could say this is the same as x squared minus y squared dy. I can integrate on both sides, and that integral will actually equal to following. Okay, the integral d of f will be the integral of x squared minus y squared d of y. And when I integrate this, you find your f is actually equal to y squared times y minus y cubed divided by 3 plus a constant c of, it's a constant c of function of x. Why is it a constant of x? Because I'm integrating in y. When you integrate in y, you're going to get the constant in the other variable. Because remember that this right here is nothing else than a function of x and y. Okay? So if I go to this is this first part. Now if I go to the second differential equation, right, that comes from df dx, okay? So from there, you can show that df dx is equal to 2 of x. And then from here, I can do the same thing, integrate 2 of x, y, d of x, integrate on both sides, and you can show that your new function f will be x squared times y plus a function in y. Okay, so now remember, because I'm integrating in x, this is going to be a function in y. Now note, I take these both equations and I have a constant here and I have a constant there. Okay, so what I can really do in the problem is I could say, I know one thing is the same function, okay? So this function is actually equal to the same functions because the functions have to be identical. So I can compare both equations and see what happens. So when I do that, you find that one equation is equal to this, plus c of x. The other equation is equal to this, plus c of y. Okay? And what you can realize here is that this term cancels out. Okay? This is a strict function of y, so the y is there. And I do not have a function in x, nothing left here in x, so we can say this is plus 0. So in other words, then my problem, I can say my c of y will be minus 3y squared, and c of x will be 0. So now if I put all these equations together, then I will end up with the following function: squared y minus 1/3 y cubed. And this has to equal to a constant. Okay? So since this has to equal to a constant, imagine if this whole constant c, okay, is equal to a c. I give different values of that constant, okay? Different values will give you different functions of this, will actually help you to realize that these are your, this is the direction in which all these stream functions are actually going, okay? So you give different values of this c, and that's how you get this plot. So this concludes this example.